Welcome to the part 2 of qualitative analysis. We'll do the preliminary test with concentrated sulfuric acid. Now, if dilute sulfuric acid test does not give us a usable result, then we can turn to concentrated sulfuric acids. So let's directly move on to the reactions. The first is the chloride ion. Now, chlorine and the reactions or the radicals we'll be doing here, one thing that is for sure is that they did not give any reaction with dilute sulfuric acid. That's why we moved on to concentrated sulfuric acid. So now first let's study about the chloride ion. So if you have a reaction or a gas being eliminated in this case, then it could be one of these acid radicals that we'll study subsequently. So if a gas is evolved, we need to check that which particular gas of this list is in it or which particular acid radical is there. So for that we have these dashed particularly. Now the first is the chloride ion. Now if it would have been chloride ion, so how can we check or confirm its presence? If on treatment with warm, concentrated H2SO4, a colorless pungent smell gas. So the first characteristic of the gas is the pungent smell. Now, and it's colorless, that we know most of them are colorless. If they are colored, I'll tell you especially about it. But if the gas which gives dense white fumes with ammonium solution, then the salt may contain Cl- ion and the following reaction occurs. Now what is the thing is that the sodium hydrogen sulfate is formed and HCl gas is released. And this HCl gas, when it is reacted with NH3, then there is an ammonium chloride which has white fumes. So the first we have to check if the smell is pungent, and if it is pungent, then we can try to pass through NH3, understood, ammonium solution. And if a white fume that is of NH4Cl is evolved, then we can trust or confirm that it is Cl minus, or we can move towards the fact that it is Cl minus. It is still not confirmed. We have to do a series of tests to be 100% confirmed. So we have ammonium chloride solution which has white fumes and it is evolved. So we have another clue that it might be Cl minus. So you need to remember these reactions. What is formed? NH2SO4 is formed. HCl gas is released, and it's not Cl2. Sometimes children confuse about this also. So this is the reaction, and then when that HCl gas and HCl and NH, this reaction is so simple. This is simple acid-base reaction, but you need to remember that NH4Cl is white fumes because you know that NH4Cl has been formed. But what are its characteristics? It might be liquid. You know, if you don't know, you don't know. So you need to remember that it has white fumes, which can be seen. Now, if a salt, now the next test, or we might say the next confirmatory test. If a salt gives effervescence on heating with conc H2SO4 and MnO2 and a light greenish yellow pungent gas. Now, what we are doing here is that we have added an oxidizing agent. Okay. What is the basic concept behind this reaction? That also we need to understand along with the reaction. So we have added a oxidizing agent, and that oxidizing agent will oxidize HCl. Understood? So, and a light greenish yellow pungent gas is evolved. This indicates the presence of Cl minus ions. So the light greenish yellow pungent gas. Now, three things: the color of the gas and the smell, that the pungent gas is evolved. So HCl was also pungent, and this is also pungent, Cl2. And what happened was that HCl was formed on reaction with H2SO4, and after that the HCl further reacted with an oxidizing agent, that is MnO2, and a light greenish yellow pungent gas is very well evolved. Now this indicates the presence of Cl minus ions. Or so this is the second confirmatory test. Understood? The state of Cl changed from -1 to 0, and manganese changed from +4 to +2. So this has very well directly confirmed us that this is a pure oxidation reduction reaction, and that's why Cl2 is formed. So the greenish yellow pungent gas, if you see, then it might confirm you that Cl2 is there. Greenish yellow pungent gas. I'm repeating this because you can remember it. Now salt solution acidified with dilute HNO3. Now the third one is we have to acidify it with dilute HNO3 on addition of silver nitrate solution gives a curdy white precipitation soluble in ammonium hydroxide solution. This indicates the presence of Cl minus ions in the salt. Now what you have to do is that you have taken AgNO3. AgNO3 will react to form NaNO3. That is simple double displacement reaction. And AgCl has a great, very small KSP. Understood? तो AgCl का KSP कम होता है इस reason से. Because of this particular reason, the white precipitation will start to occur, and AgCl can be confirmed. The white precipitate will be formed, and this AgCl, now we have to react with it with ammonium hydroxide, and on reaction there with NH4OH ammonium hydroxide. Now first one was a double displacement reaction with AgNO3, and the second one was a different kind of a reaction. That was AgCl plus 2 NH4OH will give you AgNH3 whole twice Cl plus 2H2. So this is a complex formation reaction. Understood? So AgCl plus NH4OH, that is the base, will give a complex AgNH3 whole twice Cl. So like AgCl absorbed NH3 as ligands. So it has absorbed some ligands, and H2O is released. So this test can also be performed by adding first ferrous sulfate and then conc H2SO4. So this, I think it has been written for some other part because I don't see the dot. Anyway, so this reaction is done. It's about the B part, I suppose. Anyway, let's move on. So this is an important reaction. This is a ligand formation reaction. NH3 from, we have added NH3, NH4OH, or NH3 only, but since it was in liquid state or water, in water we are considering these reactions, that's why it is written NH4OH, but we might say that we added just NH3, and you know that the common oxidation number of silver is 4 and 2, so here 2 oxidation number is being considered. So now the next topic. Now mix a little amount of salt and an equal amount of solid potassium dichromate in a test tube and add concentrated H2SO4 to it. Now you have to take a small amount of salt and in a test tube add conc H2SO4. Now heat the test tube and pass evolved gas through sodium hydroxide solution. Now you took the salt, then an oxidizing agent, and conc H2SO4. So I think HCl might have been formed, and then it might have been oxidized because I haven't read about in the next one. But what you as a student might think that I'm saying. So H2SO4, okay, H2SO4 is there, so HCl might have been formed, and then it might have been oxidized to Cl2. Now we have to heat the test tube and pass the evolved gas through sodium hydroxide solution. So Cl2 that was there was passed through sodium hydroxide solution. If a yellow solution is obtained, hmm, if a yellow solution is obtained, divide the solution into two parts. Acidify the first part with acetic acid and then add lead acetate solution. Formation of yellow precipitate of lead chromate confirms the presence of fluoride ions in the salt. This is called the chromyl chloride test. This is one of the most important tests for the chlorine and most asked also. So the test is you take NaCl, oxidizing agent, H2SO4. Now KHSO4 is formed, CrO2 Cl2 will be formed, NHSO4 will be formed, and H2. So instead of CrO2 plus Cl2, we have combination CrO2 Cl2 formed. And that CrO2 Cl2 will react with NaOH to form Na2CrO4. Okay. Yes. So now we might have CrO2 Cl2, where the Cl and O will be directly attached to chromium, and then NaOH came out, and suddenly it took away all the chlorine and reformed the NaCl, and the oxygen ONA1. So I suppose, and what would have happened is that the OH minus would have attacked on the chromium because these transition elements have a large base. So OH would have easily attached to the chromium. Now the chlorine would have left, like it is a good leaving group as you studied in organic as well. Chlorine would have left out, and it's very good at it. So chlorine had left out, and then another OH minus attacked, then chlorine left out. So we would have formed some NaCl ions. Now what would have happened is that we had some more base. So something OH, this would have like CrOH or CrO, H2Cr2, H2CrO4. And H2CrO4 might have been formed, and then this might have been acted as an acid, and then a simple acid-base reaction would have taken place, and then H plus might have been, not might have been, it is the fact. H plus will be replaced by Na, so we'll have Na2CrO4 being formed and NaCl plus water. Now, what is this Na2CrO4 special compound that's formed? So this Na2CrO4 that is formed over here will react with CH3COO, है ना, lead acetate के साथ इसने react किया, and then we'll have getting PbCrO4, lead chromate, and that lead chromate in particular has a beautiful yellow precipitate. So that's the precipitate we can identify. Now, this is that identification reaction. So now mental revision. I'm also, and you are also doing it together with me. First, we took the oxidizing agent, that was in this case K2Cr2O7. Then we took H2SO4. Then we took the salt. That is the most important part of the reaction. So now some reaction took place, and then we have got Cr2Cl2. Now that we passed through NaOH. Now we added NaOH to it, and surprisingly, the NaOH and CrO2Cl2 reacted. OH attacked over there. Then we might have been formed H2Cr O4, and then a simple acid-base reaction took place with NaOH, and finally we have got Na2CrO4, and this we further added to lead acetate, and lead acetate took a displacement reaction into place, and it displaced the Na ions, and we have lead chromate being formed, and that lead chromate in particular has a yellow color. So what was important from these? The lead chromate which led to a yellow color. We don't know if Na2CrO4, Na2CrO4 is being formed and subsequent steps, because if nothing would have reacted, then also we might see a colorless solution. So what we need here, and what is the most important part of qualitative analysis, is some kind of visible change in the liquid solution, gas evolved, some kind of visible change, and that was the yellow color here. And now we have the second part. So now what we have to do further, acidify a second part with dilute sulfuric acid and add a small amount. So we have Cr2Cl2 with us, and we have to acidify further with some dilute sulfuric acid and a small amount of amyl alcohol, and then 1 ml of 10% hydrogen peroxide solution. So we need to add the weak acid. We have CrO4 2 minus ions. I think we took the second part from here. Let me check. Heat the test tube with a yellow solution, heat the test tube and pass the wall gas to hydrogen. Divide the solution into two parts. And so we had CrO4, this only we had. So yellow solution is obtained. Okay, so this yellow solution we have to divide into two parts. So we have PbCrO4 with us. So PbCrO4 or CrO4 2 minus ions we have, and we have H plus and H2O2, that is hydrogen peroxide. On gentle shaking, organic layer turns blue. Beautiful, beautiful. CrO4 2 minus ions formed in the reaction of chromyl chloride with sodium hydroxide react with hydrogen peroxide to form chromium pentoxide, which dissolves in amyl alcohol to give blue color. So again we went to color, and that was this amyl alcohol. This you might have studied about the peroxide linkage, but this is a similar one. This one, peroxide linkage, peroxide. Yes, so CrO5 will be formed. So I think we are doing something or some sort of an oxidation only. H2O2 is an oxidizing agent, and initially Cr chromium oxide came as an oxidizing agent. Now it was oxidized and it self-reduced. Now we took some other oxidizing agent. Now it did not reduce it to Cr2O7 2-, but it reduced, oxidized it to CrO5, and that CrO5 on dissolving in amyl alcohol gave blue color. Yes. Now the next topic is bromine, Br minus. Now let's give a quick recap to what we studied up till now. See, first the basic of this is that this is the test of concentrated H2SO4. This we added dilute, no, nothing was reported, and then we added concentrated H2SO4 concentrated solution, and we get something of a gas with us. Now in case of Cl minus, we added H2, we get a pungent smell. So when we get a pungent smell, we first thought of that it might be HCl, or it might be something we first attempted. Like first we have to assume something. Now we can't prove that it is HCl with just one thing. So we have to assume that let's first cross-check. Like we have to take the first dilute test. Now if it did not happen, then we have to cross it and then take the next. Similar. So we took it to be HCl. HCl might have that smell. Now the first test we did was to convert HCl to Cl2. Now how will we convert HCl to Cl2? HCl to Cl2 was converted using a oxidizing agent. What was the oxidizing agent in this case? Because we have seen that Cr2O7 minus chromate shows some different reaction, so we could not use that. That's why we used MnO2 here. MnO2 we used, so we get some greenish, light greenish yellow pungent gas, and then we might expect it to be Cl2. Now what was the next test that was coming up to our mind? So the next test was a test of double displacement, and to form something kind of a salt which we can recognize to us. Now we thought of AgCl. AgCl is, since we have assumed Cl minus, we thought of a salt that is there, that is not dissolvable, that is AgCl, a chlorine salt that gives white precipitate. So for formation of AgCl, we had a salt of chlorine. We took that salt of chlorine with us in the solution, and then we added a salt of Ag, a silver salt. And you might expect that we added some soluble silver salt only. That's why the reaction can take place. So we added AgNO3. AgNO3 reacted, and we get a double displacement reaction product, that is AgCl. Now AgCl, we saw that AgCl was insoluble, and we got a white precipitate. So third test done very well. Now we have a subsequent step in this. We have to have a complex formation here. So we added NH3 in the solution that formed NH4OH, and then the NH3 was absorbed as a ligand to the AgCl that was formed. So this completes the third test. Now the fourth test, we thought like what to do next. So we took another. We did not take Cr2O7. So we took Cr2O7 2-, and then we started to conduct the test. So when we conducted it, we found that Cl2 gas or no gas is released, and we have a compound Cr2Cl2 that is formed. Now the Cr2Cl2 we took with us, and then we reacted with NaOH. Now O attacked and something attack happened, and then we got Na2CrO4 with us. Now that we reacted, now again we wanted some kind of a double displacement reaction to take place, because this salt. Now I think there's a pattern that we are seeing here, that if we have one salt that has come about to us, and if that is not showing any difference, or that is not being identifiable by us, then we reacted with something else to form something, some other salt that we can check that yes, this salt has been formed. So that's what the basic principle here that was used in the third C part also, where we used AgCl that was visible to us as a precipitate, and that is the same thing we are using here. Since Na2CrO4 was not identifiable, that we reacted Na2CrO4 with Pb, put lead acetate, and lead acetate again a double displacement reaction took place, and we got a lead chromate with us, and lead chromate luckily had a beautiful yellow precipitate. And then we are more interested, like we never satiable, so we reacted further with H plus. Now we oxidized it again, the CrO4 minus ions, and we reacted it with H plus and H2O2 oxidizing agent, and we finally got chromium peroxide CrO5, which now this is also not identifiable, so that further will add to amyl chloride, which will give a beautiful blue color to us. So we added this to amyl chloride, the pentoxide that was formed, the chromium pentoxide that was added to amyl chloride. Now going further, now we are coming to Br minus. So what is the test of bromine here? If on heating the salt with conc H2SO4, a reddish brown fume is obtained. Reddish brown fumes, colored fume. Now particularly we have written here colored fumes, and you might expect up till now, if you have studied, that it will be Br. It might have been HBr. Now what is the difference here? Why it was not HBr and Br, and it is Br? Now the thing is that we have NaBr, and first HBr will only be formed, but that HBr that is formed will immediately, understood, I'll tell you in a better detail, that first NaBr will be reacted with H2SO4, and we might have got HBr with us. Now that HBr went out somewhere, because reactions are step by step, we just see them directly up here, but reactions are always step by step. So that HBr might have been formed, and we have H2SO4 in solution and some NaBr that is left out. And what we see in the product, so I'm observing from here only, that you can also observe, we have SO2 here, and Na2SO4 here, and we have H2SO4. अंडरस्टूड. सो Na2SO4 इसलिए फॉर्म हुआ क्योंकि HBr फॉर्म हुआ है ना, तो Na2SO4 को रूल आउट करते हैं। तो हमें दो चीजें दिख रही है, SO2 और एक Br2, दीज आर अनयूजुअल। तो अब हुआ क्या है, यहाँ पर एक ब्यूटीफुल ऑक्सीडेशन रिडक्शन रिएक्शन टेक प्लेस हो गया है। देखिए सल्फर की जो ऑक्सीडेशन स्टेट थी वो कितनी थी, +6, और यहाँ पर कितनी है, +4। Br की स्टेट क्या थी HBr में, -1, यहाँ पर 0, तो -1 to 0 यानी कि बढ़ना, +6 to +4 घटना, यानी कि एक ऑक्सीडेशन रिडक्शन। अच्छा, ये ऑक्सीडेशन रिडक्शन रिएक्शन HCl के केस में क्यों नहीं हुआ? HCl के केस में इसलिए नहीं हुआ क्योंकि HCl and HBr है ना, तो HBr is, we can say that HBr here is a better better reducing agent. Understood? HBr is a better reducing agent than what? HCl. So that's why directly Br2 is formed. So every reaction has a logic. It's not that yes, this is this form, this is this form, and yes, yes, and so on. ऐसा नहीं है. So Br2 form हुआ. Now this is the first test. Br2 is being formed here. NaBr plus MnO2. Now the second step. Now you know the similar step. The second step is also similar. Now the thing is that तब भी Br2 ही फॉर्म होगा क्योंकि जब उसने ऑक्सीडेशन के बाद Br2 फॉर्म हुआ तो अगर अभी फिर से ऑक्सीडाइजिंग एजेंट क्योंकि पहले ही ऑक्सीडाइज हो गया तो फिर से ऑक्सीडाइजिंग एजेंट डालने का कोई भी नेट इफेक्ट यहाँ पर हमें देखने को नहीं मिलेगा तो ये वाला जो रिएक्शन है उसका कोई सिग्निफिकेंस बच नहीं गया. नाउ द नेक्स्ट स्टेप इज व्हाट इज द कंफर्मेटरी रिएक्शन फॉर दिस. Add 1 ml of carbon tetrachloride chloroform and excess of freshly prepared chlorine water dropwise to the salt solution in water और सोडियम कार्बोनेट. सबसे पहले हमने क्या किया कि एक लेयर थी हमारे पास सॉल्ट ब्रोमीन सॉल्ट की या जो भी सॉल्ट रही होगी हम आइडेंटिफाई कर रहे हैं तो हमें एक सॉल्ट की लेयर थी जो कि डिसॉल्व थी उसमें हमने एक ऑर्गेनिक लेयर डाली और उसके बाद हमने फाइनली इसमें क्लोरीन वाटर डाला ड्रॉप बाय ड्रॉप टू द सॉल्ट सॉल्यूशन इन वाटर और सोडियम कार्बोनेट एक्सट्रैक्ट न्यूट्रलाइज विद dilute HCl. Shake the test tube vigorously. The appearance of an orange brown coloration in the organic layer due to the dissolution of bromine in it confirms the presence of bromine ions. Now NaBr और Cl2 के बीच में एक रिएक्शन हुआ जिसकी वजह से NaCl और Br2 का फॉर्मेशन हुआ और जो Br2 है that was dissolved in bromine was dissolved in organic layer. तो orange brown color in the organic layer due to dissolution of bromine in it confirms the presence of bromide ions. Now what is the color? Orange color. Understood? And by this I had a good idea. Just to check it. And you can also try this one. Yellow precipitate of AbCrO4. Then we had a blue color. एमाइल क्लोराइड पे डिसॉल्व करने पर हमें ब्लू कलर था. Let's do that. So CrO5 in amyl chloride will give you blue color. Yes. Okay. White precipitate. Okay. So PbCrO4 had a yellow color. Then the CrO5 in amyl chloride had blue color, and we had reddish brown fumes in of Br. Bromine had a reddish brown color, bromine fumes, and its dissolution in what do you call its dissolution in organic layer, the bromine solution, because bromine now formed is also kind of a it's not polar anymore. So that's why some part of it might have been dissolved in the organic layer. So that's what the difference is bringing. Now chromite chloride test should be performed with minimal amount of substance to avoid a pollution by Cr3 plus ions. In place of carbon tetrachloride chloroform, carbon disulfide can be used. So any organic layer, any organic matter for that case can be easily used. Now acidify the sodium carbonate extract of salt with dilute HNO3. Okay, तो जो सोडियम कार्बोनेट है Na2CO3 उसको एसिडिफाई करोगे dilute HNO3. Add silver AgNO3 and we have AgBr. Pale yellow precipitate. So a similar reaction here, and but the color is different. A pale yellow. Understood? Kind of a precipitate is formed. So that was all about silver bromide. Okay, it was initially a yellow precipitate, and here it is a pale yellow precipitate of AgBr. Now going further, test of iodide ion. What is the test of iodide ion here? Let's check it out. So we have done Cl minus and Br minus up till now, and thankfully Br minus is a little easier than Cl2 because I think only 2 confirmatory tests are there. Now iodide ion. If on heating the salt with concentrated H2SO4, deep violet color vapors appear. This time we are sure that it will be I2 because if Br2 is better than Cl, HBr is better than HCl, then HI is obviously better. These times starch paper blue and a violet sublime is formed. Why starch paper blue? Because this is the test of starch. Understood? We have iodine. We like in smaller classes you use the test of starch in chewed food for the confirmation that the sugars in our food is converted to starch. So that's what is here being used the other way out. Understood? So we have been using a test here, that is the test of starch, and this test of starch is a beautiful test because it confirms. There it used to confirm starch, but here it is used to confirm iodine. Understood? And a violet sublimate is formed on the side of the test tube. It indicates the presence of I minus ions. Some HI, sulfur dioxide, hydrogen sulfide, and sulfur are also formed due to the following reactions. Now, what are the subsequent formations that we'll see out? So first of all, I2 is released and SO2 is formed. I think I told you that an oxidation reaction is taking place. That's why SO2 is formed. So NaI plus H2SO4 will give you NaHSO4 plus HI. Understood? So what NaI H2SO4 give NaHSO4 plus HI. Now HI, that this is the reaction that I told in BR. Here it is written in detail. HI plus H2SO4 will give H2 plus I2 plus SO2, and then NaI plus H2SO4 will give you I2 plus H2 plus S plus 3 Na2SO4. This is the other. Like first, in this case, the sulfur oxidation was reduced from plus 6 to plus 4, and here it was reduced from plus 6 to 0 directly. है ना? So this is also an oxidizing agent, just the product is different. And here it was reduced from plus 6. This is a beautiful one. Plus 6 to minus 2. So this is another one. Plus 6 to minus 2 directly. So that's the H2. So these are the other products that are formed. On adding MnO2 to the reaction mixture, the violet vapors become dense. Why dense? Because HI when formed, it was acting as a reducing agent and it was being oxidized by H2SO4. Now if you add an oxidizing agent to it, then the oxidation process for HI will be even faster. And the violet vapors will be densely or at a great rate, because here many products are there and different things problems might occur. So it might not be easy to identify the violet vapors. So this MnO2 addition we can use here to confirm our reaction. Okay. So violet sublimate is formed, deep violet vapors. I think I will use a quite deep color. Anyway, now next test, add 1 ml of CHCl3 or CaCl4 chlorine water next to the salt. Now you remember in case of HBr, Br2 we found a greenish color. If you don't, I'll show you. Yes, yes. Sorry, not green, orange brown color. Orange brown color. Yes. And what was the color of Br2 vapors? It is very difficult to remember. The reddish brown. I think they're great colors, red color, blue color. These vapors are a treat to the eye, I suppose. So red color vapors, yellow, violet colored vapors, and yes. So we have presence of violet coloration in the organic layer, confirm the presence of iodide ion. तो organic layer में अब क्या होता है, violet coloration होता है. One thing did you notice that the vapors of the vapors of Br2 were deep red or red colored, understood? And the coloration of Br2 in the organic layer was orange brown shade of it, lighter shade I suppose. And the vapors of iodine were deep blue in color. Yes, and they're layered in the organic part. This you'll enjoy, I suppose. I don't know if it's a coincidence or some reason is there, because I think the properties of it are not changed. If little is dissolved, violet, है ना? Properties को तो नहीं change होना चाहिए. तो शायद यही कारण हो. Violet coloration. Yes. So now acidified sodium carbonate extract. Yes, so all of it has been violet up till now. Violet vapors, blue, starch vapor. Yes, blue, starch vapor. Then violet vapors, violet coloration. Now the third test, acidified sodium carbonate extract of the salt with dilute HNO3. But then again the AgNO3 test. So that's beautiful. AgI and another color, yellow precipitate. First we had a colorless one. Then we had the pale yellow one, a yellow one again in case of AgI. So that's why you have many tests, because some of the properties might similarize in cases. Understand? कुछ केसेस में कुछ प्रॉपर्टीज या जो कलर चेंज है वो सिमिलर दिख सकता है, जैसे कि यहाँ पर AgI और AgBr के केस में दिखा हमने. तो इसी से बचने के लिए हमने मल्टीपल टेस्ट को डिजाइन करा है. Yes. Now test of nitrate. If on heating the salt with conc H2SO4, light brown fumes are evolved. Then heat a small quantity of the given salt with few copper turnings or chips and conc H2SO4. Evolution of excess of brown fumes indicates the presence of nitrate ions. Now, first we had colorless fumes with a pungent smell. Then we have red fumes, then blue fumes, and we have now light brown fumes with us. Then heat a small quantity of the given salt with few copper turnings of chips and conc H2SO4. Now we added some H2SO4 हमने ऐड कराई था. अब हमें copper turnings भी हमने ऐड कर दी. Evolution of excess of brown fumes indicates the presence of nitrate ions. The solution turns deep blue due to the formation of copper sulfate. वो तो वैसे भी हो जाता अगर हमने कॉपर ऐड करा होता H2SO4. That ignore that part. NaNO3 plus H2SO4 will give NHSO4 plus HNO3. HNO3 as you know will break into NO2 and O2. And NaNO3 we had copper, so NO will be formed. So we had light brown fumes and now we have brown fumes in particular. Yes. So this was the difference. These brown fumes indicate that NO has been formed. NaNO3 plus H2SO4 will give you NHSO4 plus HNO3. HNO3 will give you NO2, and in case of copper, we'll be getting NO. Now, why did we get that? I think here also some oxidation reaction might have taken place. Why? Because copper was 0 and it turned to -2, +2. Yes, and NO was +2, and now it has become -2. NO2 was +4 and now it is +2. So I think here also some kind of oxidation reaction has taken place. And NO now initially, remember that it was NO2 gas and now NO gas, though same color, similar color, but the gas is different. And NO will react with O2 to form NO2 further. Now the next thing is, take 1 ml of an aqueous solution of the salt and add 2 ml conc H2SO4 slowly. So we have taken 1 ml of an aqueous solution of the salt and added 2 ml of H2SO4 slowly. So this we were doing up till now. Mix the solution thoroughly and cool the test tube under the tap. Now add freshly prepared ferrous sulfate solution along the sides of the test tube dropwise so that it forms a layer on the top of the liquid already present in the test tube. A dark brown ring is formed at the junction of the two elements, two solution due to the formation of nitroso-ferrous sulfate. Alternatively, first ferrous sulfate is added and then sulfuric acid is added. So what is happening is that we added H2SO4. Understood? We had HNO3 being formed and it was to be decomposed. Now, to prevent the decomposition, we rapidly cooled it with under tap water. Now we have HNO3 with us, H2SO4 with us. What we did now was we added FeSO4 through the sides of the test tube. FeSO4 ऐड करने पर क्या होगा कि एक ऑक्सीडेशन रिडक्शन रिएक्शन टेक प्लेस होगा. FeSO4 में Fe की स्टेट क्या थी +2, अब उसकी स्टेट होनी है +3. अगर उसकी स्टेट +3 होने से रिएक्शन में बीइंग रिएक्टिवली रिलीज्ड NO अगर रिलीज हो गया, NO अगर रिलीज हो गया तो वो FeSO4 से रिएक्ट करके एक कॉम्प्लेक्स बनाएगा जो कि ब्राउन कलर का देखा जाएगा, nitroso-ferrous sulfate, which is also brown. I think I can't tolerate this anymore. Everything is brown here for NO3 minus. I think it loves brown color, I suppose. Its fumes are brown, then NO fumes are brown, then FeNO-SO4, this what you call the complex is also brown. Oh man, what? Hello. Next. Now what is the next ion waiting for us? The oxalate ion of C2O4 2 minus ion. If carbon dioxide gas along the carbon monoxide gas is involved in the preliminary examination conc sulfuric acid, this gives indication about the presence of oxalate ion. And this also gives you an idea that carbon dioxide gas would also have been involved with CO3 2 minus would have been there, carbonate would have been there. But if the difference is that CO3 2 minus would have produced carbon dioxide even on reaction with dilute sulfuric acid, but C2O4 2 minus has produced only when it reacted with conc sulfuric acid. So CO2 and CO we have, and we have Na2SO4, H2O, CO2 and CO. So this we have. Okay, this gives indication about the presence of oxalate ion. तो अगर हमें कोई कलरलेस ओडरलेस, अभी तक जो हमने देखा हमने किया तो किसमें कलर था या ओडर था, है ना? यही आप देखिए इसमें कलर भी नहीं ओडर भी नहीं और एक ग्रेस फ्रेग्रेंस का टाइप का भी कुछ है. एंड नाउ द नेक्स्ट थिंग इज, अब क्या करना है? यस, COONA whole twice plus conc H2SO4 will give you Na2SO4 plus H2 plus CO plus CO2. आई थिंक यहाँ पर कुछ गलत लिखा है. C2O4, अच्छा ठीक है, ये आएगा ना C2O4 Na2, so that's what is written here. Okay, so this is oxalate ion with us and we'll get CO and CO2 that is released. Yes, है ना? H2 C2O4 बनेगा और जो H2 C2O4 बनेगा वो H2O plus CO2 plus CO में डिकम्पोज इजीली हो जाएगा. So oxalate ion is confirmed by the following test. अच्छा, ये वाला रिएक्शन याद है अपने ऑर्गेनिक में किया था? H2 C2O4 will decompose into H2O and CO2 and CO. So remember this reaction. I think you might have done this reaction. If not, then it's an important one. You need to remember it. Understood? Yes. Now going further. Oxalate is confirmed by the following tests. Now what are the confirmation tests for the oxalates? Acidify sodium carbonate extract with acetic acid and add calcium chloride solution. तो हमने क्या किया, जो सोडियम कार्बोनेट एक्सट्रैक्ट हमारे पास था, हाँ, Na2CO3 with acetic acid and add calcium chloride solution. A white PPT of calcium oxalate insoluble in ammonium oxalate and oxalic acid solution indicates the presence of oxalate ion. अब तो हमें एक पीपीटी एक कुछ मिला और उसे जब हमने डिसॉल्व किया, कैसे डिसॉल्व करेंगे? हम उसको पहले अगर जो बन गया होगा CaCO4 उसको हम हीट कर सकते हैं पानी में अगर है तो, और हीट करने के बाद जो उसका सॉल्ट बना उसे हम ट्रांसफर कर सकते हैं इधर इन अमोनियम ऑक्सलेट और ऑक्सैलिक एसिड सॉल्यूशन में. तो क्या हुआ कि हमने कैल्शियम क्लोराइड का सॉल्ट लिया और हमने अपना ऑक्सलेट उसके अंदर ठोस दिया. उसके बाद क्या हुआ कि जो है वो उसको जब हमने डिसॉल्व करने की कोशिश की अमोनियम ऑक्सलेट में तो डिसॉल्व नहीं हुआ. That confirmed that it is oxalate only. Now the next test or the confirmatory test is KMNO4 test. Filter the precipitate from test A, add dilute H2SO4 to it, followed by dilute KMNO4 solution and warm. Pink color of KMNO4 is discharged. CaC2O4. Now हमने क्या किया, हमने जो H2C2O4 बना था उसे डायरेक्टली यस CaSO4 से रिएक्ट करा दिया. टेस्ट ए का जो प्रेसिपिटेट था, सॉरी यस नाउ आई एम एट राइट ट्रैक. टेस्ट ए का जो प्रेसिपिटेट था CaC2O4 उसको हमने H2SO4 से रिएक्ट कराया और H2C2O4 बनेगा, ये आप जानते हैं. एक चीज और बन जाएगी बच्चों, CaSO4 भी बन जाएगा. वो तो बनेगा ही क्योंकि डबल डिस्प्लेसमेंट रिएक्शन है सिंपली. यस, तो CaSO4 भी बन गया हमारे पास. अब क्या हुआ कि जो H2C2O4 है और H2SO4 है एंड KMNO4, इन तीनों के बाद में जो रिएक्शन हुआ उसमें MnSO4 तो एक तो रिड्यूस हो गया, A2SO4 H2 एंड CO2 पास गया टू लाइम वाटर एंड द वाइट लिक्विड इज फॉर्म्ड. तो CO2 का आयोनाइजेशन यस वो होना चाहिए H2C2O4 के साथ रिएक्ट करने पर. तो एक सिमिलर है, इनिशियली जो हो रहा था वही हो रहा है, बस हमने एक ऑक्सीडाइजिंग एजेंट का अलग से यूज करा है इस केस के अंदर. ओके, so this is all for the second test with us.